So this problem is called testing a population mean, and it says test the claim that the population mean mu is bigger than 750 given a sample size of 36 for which the sample mean x bar is 800 and the sample standard deviation is 100. Then it says use a level of significance of 2%. Okay, so we know this is a hypothesis test because we're testing a claim, and usually in statistics when you test a claim you do that in the form of a hypothesis test. So for a hypothesis test we need two things. We need to figure out what the null hypothesis is, that's the initial claim, and then also what the alternative to that is as well. Now in this case it says test the claim that mu is bigger than 750. And we know that the null hypothesis always comes in the form that the population mean is equal to some value. So we know that this first statement up here isn't the null hypothesis, but this has got to be the form for the alternative hypothesis. So the value that we want to test, if we look at this, has got to be 750. So for the null hypothesis, I'm going to write mu is equal to 750. And then the alternative to that is that mu is bigger than 750 in this case. Okay, so the way a hypothesis test works is we take a test statistic and then based on that test statistic we try to decide whether or not we reject the null hypothesis or not. And in this case the null hypothesis is that mu is 750. So we'll take our test statistic and see if that winds up being too big to make us believe that claim. Okay, so the test statistic in this case is this x bar is equal to 800, so let's write down x bar is 800. Let's also put in that the sample size was, what, 36, and the sample standard deviation, which we'll need as well, is 100. Okay. So let's draw a picture of the x bar distribution and see if we can figure out where the various parts of this problem are. So here we're going to draw x bar, and let's draw the distribution for that. It looks something like this. It's a normal curve, and in the middle of the normal curve we know is this population value, population mean, this proposed population mean value, and that's going to be 750. So let's put that there. Now over to the right of this is the test statistic. There's our 800, so that's got to be somewhere over here, and let's draw that in there. Now the area that we're looking for, the thing that we're looking for, because this alternative hypothesis has this form where mu is bigger than 750, that tells me this is a right-tailed test, and I'm looking for the area that's to the right of the test statistic, so that's the tail over here like this. So this is a right-tailed test, and I can tell that by looking at the alternative hypothesis. You can always tell whether it's a right-tailed, left-tailed, or a two-tailed test based on this form down here. Alright, so I'm looking for this area over here, and the size of this area is called the p-value. So once we get that area, that'll be our p-value. And the way you decide a hypothesis test is you take the p-value and compare it to the level of significance that was given to you. So in this case the level of significance was 2%, so let's write that over here as well. Our alpha is 0.02. So we're looking for a p-value to compare to this 0.02, and if the p-value is smaller than that 0.02, then that's evidence against this H0, the null hypothesis. Okay, so how do we get this p-value? How do we get this area? Well, we need to look up an area to the right of the test statistic, and the way to do that is to change the test statistic into a normalized a score, and in this case we're going to use a t-distribution to do that, so we're going to change things into t-values. Now this curve looks about the same, like this. And in the middle of this t distribution over here will be the thing that corresponds to this 750, and that's going to be 0. Now where's the area that corresponds to the test statistic over here? Well, there'll be a t-value about right here that we need to find, and then once we find that, that'll give us the area over here of this tail, And then that's going to be the same as this area back here in the x-bar distribution. All right, now how do we get this t-value over here then from our test statistic? Well, you write down the t-score, and it looks like this, data minus mean, and divide by the standard deviation, where this time the data is our x-bar value from the sample mean, and that's 800. And the mean we're testing here is the 750, so let's put that in. And now the standard deviation on the bottom, though, we need to be a little bit careful. It's not just the sample standard deviation that was given to us, but in this case, because we're dealing with the x-bar distribution, it's the sample standard deviation, but since things are clustered much more closely near this 750, to account for that, for the x-bar distribution, we divide by the square root of n down here. So that's 100 on the top, and the square root of 36 on the bottom, so it's about 100 over 6. And that turns out to be about 16.67. So let's put that up here, 16.67. And then if we do the math up here, we get 50 divided by 16.67. And that turns out to be about 3 for a t-score. Okay, so over here, the t-value that we're looking for is 3. And then we just need to find the area to the right of that t-value to give us our p-value. So the p-value is going to be equal to the area of that right tail, and we're going to get that from Excel, or we're going to write down the function that would give it to us in Excel. You can also look these up in tables, but it's a little bit better to just use Excel. So the Excel function that gives you the p-value once you have t-score is tdist, and if you put in the t-value into the first slot, then the degrees of freedom into the second slot, which is the sample size minus 1. So we're going to put in 35 there. And then for the last slot here, you say whether it's a one-tail or two-tailed test. Now, if we look in Excel, if we do this work in Excel, it gives us 0.0025 for that p-value. And so that means that this area up here is 0.0025. Now, our alpha value is 0.02, so the question is the p-value smaller than 0.02? And it definitely is. So the p-value here is smaller than 0.02, and when the p-value is very small, that's evidence against the null hypothesis. So up here we're going to say that leads us to reject H0, and in this case, if we reject H0, that's then evidence for the alternative hypothesis, which was the original claim up here, that mu was bigger than 750. So we did find evidence for the alternative here in this case.